couple of warm-up problems for you. It's the only two graphs that we have, but I'll pass out. If you have, no, you need some? Okay. I couldn't remember if we needed graph paper, if we had some left out. I'll give you some here. Just start fresh. All that kind of stuff. Looking ahead to this week, we've got, we're going to start doing some stuff algebraically. So we're going to get away from the graphing a little bit. And then on Friday, we're going to have a quiz. And that quiz is going to be a summative one this time. But it will cover everything in this unit so far. So there will be more graphing and more of that stuff on it. Okay? So try these two wonderful. Did I give you one? Literally walk past? That's probably my fault. Now, to be clear and fair, Roth came up with these two, just so you know. Okay? Okay? Here we go. So, first one, y-intercept is 0, right? Okay? Right? Slope is negative 2 over 3. So if I'm there, then I'm going down 2, right 3. Down 2, right 3. Down 2, right 3. Down 2, right 3. Or up to left. Solid or dashed line on that one? That's a dashed line, isn't it? Yeah, that's a dashed line. Okay. But we went through the origin, correct? So can I use that as my test point? Nope, can't use that as my test point. So I got to pick something else. So I'm going to pick the point 6, comma 0. Now you may be asking yourself, why did I pick 6, comma 0 as my test point? Well, I did it because it's 0 for y, and negative 2/3 times 6 is 4, or it's actually negative 4. Okay? So that's why I did it. Is 0 less than negative 4? No, that's false. So that means that I am then going to be shading on this side of said line. Agree? Okay. Then we got x. We got, oops, that is what I wanted. X minus 2y equals 4. Then we're going to go negative 2y equals negative x plus 4. Then we're going to go y equals positive 1/2 x minus 2. So that's going to give me a y-intercept of negative 2 and slope of positive 1/2. Solid or dashed? I want solid. Didn't go through the origin on that one. So that's going to be 0 minus 2 times 0 greater than or equal to 4. Another falsitude. So that means my So, agree? Questions, comments, concerns, clarification? Okay, love it. Now let's go to this next one. Or actually, let's go back to the first one. So y equals negative 2x plus 4. That's going to be, this should go here, and then here, and then negative 2x plus 4. So that's a y-intercept of positive 4, and a slope of negative 2. So that's down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1, so on, so forth, up to, oops, I put it in the wrong spot, up to, up, and so on, and so forth. Yes? Love it. Next one. Oof. Lincoln, what was wrong with this one? Three and a half, but it should be 7.5, which is 3.5, right? So then I'm going down 3.5. And then from there I'm going up 3, 2, and 3, right 1. Up 3, 1, 2, and 3, right 1. 1, 2, and 3, right 1. 1, 2, and 3, right 1. 1, 2, and 3, left 1. 1, 2, and 3, left 1. You know what I mean? Not nice. But when I grab it, what are we thinking for an intersection point? For a solution, if you will. What are we thinking about that point right there? What's the coordinates of that point? 1.2? Let's try 1, because it looks to be about halfway, right? So let's go 1, 1.5, comma 1. How do we test it to make sure it's right? We got to plug it in back into both of them, right? Okay. So if I test it in the first one, 1 equals negative 2 times 3/2 plus 4. That's going to be negative 3 plus 4. That's going to be 1. So it works out in the first one. Yes? If I plug it in the second one, six times 3/2 is 9. 9 minus 2 is 7. 7 equals 7. There it is. Works out. The reason that we're learning about what we're learning about today, the algebraic way to solve these, is just because of this example right here. Okay? It doesn't make, we got to kind of guesstimate where that intersection point happens. We don't like to guess, we like to know. Okay? And so how we're going to go about doing that is we're going to explore 2 more options. The first option is we're going to solve a system of equations by substitution. Now, what I would like you to do is I would like you to struggle through this. And maybe for some of you it's not a struggle. But I want to see what you know about this one. So I'm going to give you a couple of minutes to solve this system of linear equations. Red and blue are your 2 equations. solve this system by substitution. Go. I'll give you a couple minutes to solve. We're going to actually do this one on the next one when we actually have a strategery, because there it is. Should be the same one. 3x, what? Yep, it is. Yep, it is the same one. Okay? Solve. All right. So what you should have done. So let's go this solving by substitution. Here's our strategy. Okay? So the first thing that we are going to do is you are going to solve one of the equations for one of the variables. That's what you should have done first when you're solving by substitution. Now, I got in there in blue, be smart. Okay? So we either got to solve the first equation for x, the first equation for y, the second equation for x, or the second equation for y. Okay? Which is the smart one to solve for? Second one for which one? The second one for y. Why is that, WHY, is that the smart one to solve for? Because it's just y, right? Okay? It's just y all by itself. Okay? So I'm going to solve this equation for y. So by doing that, I'm going to have to add 2x to both sides, and that gives me y equals 4 plus 2x. That's the first step. You've got to get one of the equations or one of the variables. Doesn't matter which one, it all works out. Second step, we are going to substitute that. We're going to put this, what we just substituted in for, into the other equation in place of that variable. So this is going to be 3x plus 2. Now instead of y, we're going to put 4 plus 2x. And that's going to equal 1. Third step is we're now going to solve that single variable equation. So let's solve this bad boy. So that's going to be 3x plus 8 plus 4x equals 1. That's 7x plus 8 equals 1. That's 7x equals negative 7. That's x equals negative 1. With me on that so far? Okay. Now, we're going to substitute that answer back in here to get what y is. So now this is going to be y equals 4 plus 2 times negative 1. That's going to be 4 minus 2. That's going to be y equals 2. Now, the last step is the most important step. And the last step says now we're going to write our answer in point form, which means that we're going to write our answer as x, comma, y, and we've got to check it to make sure it works, to make sure we did our math correctly. Okay? So if I check it back in the first one, 3 times negative 1 plus 2 times 2 has to be 1. Negative 3 plus 4 is 1. 1 is equal to 1. If I plug it back in the second equation, -2 times -1 plus 2 has to be 4. 2 plus 2 is 4. 4 is equal to 4. So therefore, that is our answer. We done did it. Okay. Solve that system of equations using substitution. What's the smart variable to solve for? X in the right equation. Yep. Okay. So if I solve for x here, that's going to be -9 minus 5y. So then I'm going to put that back into this equation. That's going to give me -36 plus minus 20y plus 3y equals -2. So then that's going to give us -17y minus 36 equals -2. That's going to give us -17y equals +34. That's going to give us -2. If I plug in -2 back into this one, then that's going to be -9 minus 5 times -2 is going to be -9 plus 10 is going to be +1. If x is 1, then I've got 4. If y is -2, that's -6. 4 plus -6 is -2. If x is 1, then that's 1. If y is -2, then that's -10. 1 plus -10 is -9. The answer is 1, -2. What happens if I wrote this as 2, -1? Same numbers. Would it be right though? No, because that's a different point. That's a different point space if I flip-flop the x and 1. Okay? So it's got to be in that specific order. And even though we first got -2, we second got +1, it's got to be in that right order. Okay? All right? Yeah. Good times. Good times. We get to deal with some fractions now. Solve this equation using the substitution. Does my strategy change if there's fractions? Nope. Strategy doesn't change even if there's fractions. Same thing. Same steps. Nope. What's the easy variable to solve for? Y and which one? One on the top? Okay. Then I'm dividing by 3, right, on -34? Doesn't work out, right? No. No. Actually, solving for y on the second equation is the easy way to go. Because what do I need to do? At some point in time, what am I going to need to do to get y by itself? I'm going to have to multiply by 4, right? At some point in time. So let's do that right from the start. If I multiply by 4 right from the start, 4 times 1/2 is 2. 4 times 1/4 is 1. 4 times negative 1/2 is negative 2. I can do that right from the start. I can multiply both sides by a number to clear the fractions if I want. And then, now, I can add y to both sides, while at the same time adding 2 to both sides. The adding of the y cancels there. Adding of the 2 cancels there. And then that leaves me with 2x plus 2 equals 1. Okay? For the easy one. Okay? Now, back here. We'll still get the same answer, no matter what variable we solve. You know what I mean? It just might be a little more fractional type work as we go through it. Okay? So now we can plug that back into the other equation. 2/3 x plus 3 times 2x plus 2 is going to be negative 34. Two-thirds x plus 6x plus 6 is negative 34. Six and 2/3 is what I would get here for my axis, but that's going to be 20 x over 3. Make it be that nice and pretty. I'm going to subtract 6 right off the start, and that's going to be negative 40. And multiply both sides by 3/20. You could multiply both sides by 3, then divide by 20, same thing. It's going to give me x equals negative 6. If I plug in x equals negative 6, we go back into that first one. 2/3 times negative 6 is negative 4 plus 3y equals negative 34 plus 3y equals negative 34. Subtract, or don't add 4 to both sides. y is negative 30. Divide both sides by 3. It means y is negative 10. Negative 6, comma, negative 10. Negative 6 times 2/3 is negative 4. 3 times negative 10 is negative 30. Negative 4 plus negative 30 is negative 34. Checks out the first one. Negative 6 times 1/2 is negative 3. Negative 1/4 times negative 10 is 5/2. 3, which is 6/2, to negative 6/2, plus 5/2 is negative 1/2. It checks out. Works out there. Yep. One last one. Yes, there will be word problems in this stuff. Okay? Key to a word problem, you got to read it. second key to a word problem, you gotta make an equation. For every variable that you have, you gotta have an equation. So if you make up one variable, you only gotta come up with one equation. You make up two variables, you gotta have two equations. Okay? So $2,384 in revenue was made from the 378 adult passes and 214 children's passes sold to the county fair. An adult pass costs $2 more than a children's pass. Find the cost of an adult pass and a children's pass. So we've got an adult pass and we've got a children's pass. So let's go with A is adult and C is children's. So I came up with two variables, which means I got to come up with two equations. First equation is going to be 378 adult passes. We don't know what the cost of an adult pass was, so we're going to call that A, plus 214C gets me $2,384. Second equation, an adult pass is $2 more than a children's pass. So A equals C plus 2. Substitution set up for us already, right? Because we've solved one of our equations for one of our variables. Second one is A equals. So we can plug that right away into our other equation. Oh, what do we got? 378C plus, somebody with a calculator, 378 times 2. 6, 5, 756. Uh, 378 plus 214. 592. $2,384 minus 756. 1628. Divide that by 592. 3? 250? 2.75? So a kid's pass costs $2.75. If a kid's pass costs $2.75, how much does an adult pass cost? $4.75. Now, when you're giving those answers, because this is a word problem, you got to tell me which one is which. Just telling me $2.75 and $4.75 doesn't tell me which pass cost what. You've got to be specific when you're describing what the answer is to a word problem. Okay? You can do the first 3 on this homework for this week.